All right, 4.6a. So I broke it into two parts. The first part of our 4.6 notes, we're going to talk about absolute value function transformations. So what causes the function to go up, down, left, right, and our vertical stretch and compression. Okay. So we've done this before, roughly, and when we talked about our parent functions quickly, but transformations are a change from the parent function, right? You are comparing how, you don't have this in there, you are comparing how a function has changed. Did it go left, right, up, down, stretch, compress, and or reflect? So we're going to start here. You should have this. So this is our transformation rules. So these are what happens, what causes a function to translate. The only difference here is that you'd be like, oh, there's no absolute value. Well, this is just saying if for any function, this is what happens. This is the standard form of it, okay? Vertical transformations, okay? Your vertical transformations come from your K value. Your K value tells you whether you're going to go up or down, okay? Horizontal transformation come from your H value. Your H value tells you whether you're going right or left. And you need to be careful because this, remember, our X's lie. So even though it looks like it's saying minus H, it's actually a positive and you're going to the right. Okay. Uh-oh. Oh, I wrote there. I wrote something very weird here. One of the inequalities needs to be flipped. This guy, sorry. All right, so here we go. Vertical stretch and compression. Your vertical stretch and compression is saying how skinny or wide your function is going to be. So if A is greater than 1, then it's going to be narrow. Okay, that means it's long. If it's less than 1, it's going to be wide. Okay, and it has to be greater than 0 otherwise. But remember, this is also your slope. Lastly is your reflection. So reflection of y equals absolute value of x. There is no reflection on the inside because the negative is going to become a positive, but the graph of the parent function is reflected on the x-axis. So instead of being this, I become this. Cool. All right, let's apply it. So analyzing without a graph. So the first thing you're going to do is identify all your variables, your A, your H, your K, and go from there. Then you're going to identify the vertex and the axis of symmetry. Your vertex is your H and your K. X equals H is your axis of symmetry. And then you're going to describe how the graph physically changed. Did it go up, down, left, right, stretch, compress, or reflect? All right. So we have y equals the absolute value of x minus 1 plus 2, okay? And we want to know, without graphing, find the vertex, axis of symmetry, and transformation, okay? Your vertex again is based off of your H and your K. So we're going to identify our H and our K first, right? What is our H equal? 1, perfect. And what is our K equal? 2, perfect. And then our A determines whether it's a max or min. If A is positive, so positive A, I wrote that backwards. Hold on, did something weird. There it is. If it's a negative A, you have a max. If you have a positive A, you have a min. So our A equals what? If there's nothing there, who's there? 1. So it's a positive 1. So now we have our variables. Can we describe everything else? Yes, our vertex, A is 1, positive 1. So we have a minimum vertex at, and what's our H and our K? 1, 2. So we have a minimum vertex at 1, 2. Our axis of symmetry is solely based off our H. Your axis of symmetry is X equals H. So what is our axis of symmetry? X equal 1. And then we're going to talk about our transformations. Well, A is just 1. So there is no stretch or compression. There's an orange stretch, isn't there? I got it. I squeezed it in there. H is 1, and our H is our horizontal movement. So if I'm a positive 1, that means I went to the right 1. So we translate right 1. K equals 2. So that means I did what? We went up 2. So just from this function, if you were giving any of these questions, you should be able to answer it. Okay. If it asks you what kind of vertex you have, you should say, I have a minimum vertex. If it asks you what's the axis of symmetry, you should be saying, oh, that's my H. So at X equals 1. If it asks what transformations took place, A equaled 1, so no stretch or compression. H equals 1, so I went right 1. K equals 2, so I went up 2. How do we feel? Doable? All right, let's try another one. So here we have Y equals 3 absolute value of X. So we're going to identify our A, our H, and our K first. What is our A? 3. What is our H? Is there anything there? When there's nothing being added or subtracted, then they are 0. All right. So we got to determine, do we have a maximum or a minimum vertex? Remember, if it's a negative A, you have a max. If it's a positive A, you have a min. We have a minimum because our A is what? Positive. And your vertex is at your H and your K. So what is our vertex? At 0, 0. Your axis of symmetry is X equals your H. So whatever your H is, 0. So X equals 0 is our axis of symmetry. Okay. A. So A is our vertical stretch or compression. Remember, it's a stretch if A is greater than 1. So since our A is greater than 1, we have a vertical stretch by 3. Because A is greater than 1. And when H and K are 0, then no shift. We did not go left, right, up, or down. All right. Are we ready for example C? So example C. Someone tell me, what is my A? -3, good job. What is my H? Good job. X is a liar, -1. What is my K? 2. Was there anyone who has a hard time identifying A, H, and K? We're good? Okay. The vertex. So your vertex, again, depends on whether your A is positive or your A is negative. So in this case, we have a what? What is our A? -3. I wrote them backwards again. What is wrong with me? You were gonna wait to say something? You never saw that. All right. What is our A? So that means we have a what? A maximum vertex. So we have a maximum vertex at what? Our H and our K. -1, 2. Good job. That's the worst at symbol I've ever drawn. Let's try that again. That's better. All right, axis of symmetry. Your axis of symmetry is based off of your H. What is our axis of symmetry? -1. X equals -1. All right. Our A tells us whether we have a stretch, compression, or reflection. Okay. So our A is negative. So what does that mean? It reflected. Yeah, it reflected. So we reflected. Did I spell reflected wrong? I feel like I did. Let's try that again. Reflected over x-axis. And then the absolute value of our A equals 3. And so it's a number greater than 1. What does that mean? Is that a stretch or a compression? It's a stretch. So we have a vertical stretch by 3. So it reflects over the x-axis and there's a vertical stretch by 3. What does -1 mean for the H? Remember, that's our left and our right. Did I go left or right? I went left 1 and I have a +2 for my K. So what does that mean? I went up 2. And look, we did all of this without graphing. Now, when you're taking your test, if you feel like you need that safety net of graphing it just to make sure you're right, then by all means, take it out, graph it, and you should be able to see that you were right, right? Okay, how do we feel? So now we're gonna go backwards. All right. So here we were given the function and then we have to describe it, right? Without a graph. Now we're going to be given the graph and we have to find the function. So we're going to go backwards. So the first thing we're going to do is identify our vertex, find our slope, which is our A value, and then we're going to substitute the values back into the general form. All right. So if you could at the top of your paper write y equals absolute value of x minus h plus k above example 1 or example 2 on the back. Be great. So you're writing y equals absolute value of x minus h plus k. All right, ready? So working backwards, we're going to identify the vertex. We're going to also talk about intervals of decrease and increase. And then we're going to substitute things back in. Okay, so here, step 1 is to find the vertex. Our vertex here is a maximum, right? Agree? So it's a maximum vertex and it's where? At -1, what? 4. There we go. So we found our vertex. Step 2 is to find our slope because our slope equals our A. So finding your slope, that's your rise over run. Do you remember doing that? So when I'm trying to go from here to here, I go down how many? 1, so that's negative. And then I go to the right, 1, 2, 3. So therefore A equals -1/3. Okay. We also have to talk about our intervals of increase and decrease. So when you have a maximum on the right-hand side, you are, left-hand side, you are increasing. Does that make sense? So we increase on the left from -infinity up until -1. And then on the right-hand side, we decrease from -1 to +infinity. Do we see that? So those are our intervals of increasing and decreasing. And now we're going to put it all together. So we have our H, we have our K, and we have our A. So y equals, what's A? -1/3 absolute value of x minus -1. What's a negative times a negative? A positive. and our k is 4. And so there it is. We work backwards. How do you feel about working backwards? Huh? Okay. All right, let's try another one. So working backwards again. We're going to write the equation. So the first step is to find our vertex. Where is the vertex? 2, -1, agree? And we have a minimum vertex. And it's at 2, -1. So that means my h and my k are found. Step 2 is to find your slope, which equals your a. So from here to here, I'm going to go up. I rise 1, agree? And then I go 1, 2, 3, 4, 4 to the right. So therefore my slope is 1/4. If it asks me to describe my intervals of increase and decrease, when it's a minimum, notice on the left hand, I am decreasing, and on the right hand, I am increasing. So my decreasing interval is from -∞ to 2, and my increasing interval is from 2 to infinity. It's always going to be your h value for the stop and start of your increasing. Because that's where it changes directions, right? At your axis of symmetry. So now we've analyzed, we're going to put it all together. So we have y equals, what is a? 1/4 absolute value of x minus h. What is h? 2 plus or minus our k, and our k is -1. How do you feel? All right, here you go. You're going to try it. And then we're done. We're done with absolute values after this. All right, so the first thing you're going to tell me is the vertex. What was the vertex? Good job, 0, 3. So we have our h and we have our k. The second thing you're going to tell me is the slope, which is our a. What was the slope? We go up 4 and we go over 1, right? So because it's a minimum vertex, on the left side, we decrease from -∞ up until 0. And on the right side, we increase from 0 to infinity. So we put all of it together and we get y equals what? What's my a? 4. Did I have an h? No. And what's my k? So y equals 4 absolute value of x plus 3. All right, so these are page 71 of your notes.